In this playground competition, we are going to predict the fare amount for a taxi ride in New York City, given the pickup and drop-off locations. Of course, we can get a basic estimate based on just the distance between the 2 points. That will result in a deviation of $5 or $8, depending on the model used. We are going to do better than this using machine learning technique. The first part, cleaning date. We need to screen out the date that is not logical and remove them as invalid date. It's easy to analyze and model later. First of all, we load the file of train.csv and just read the top 10 million rows so that the kernel won't die easily. And we have looked the top row of date. The function of info used to display the date for each column in table. That is an attribute name for each piece of information. And for each date attribute, the corresponding data characteristics are contained, such as maximum, minimum, number, history, and are displayed as a format of float. Regarding the result, some records are definitely wrong. For example, the taxi can only have at most 5 passengers. We should check those out now. And then we filter out the correct date through the log function. First, the amount paid must be greater than the minimum charge for a $5 taxi. The cost must be less than the furthest distance. We estimate $600. So these are the numbers that we left with after screening. And since the latitude of New York City is almost 40 and the longitude is almost 73, we set latitude range between 71 and 75.5, and we set the longitude range between 40 and 42, without both of drop-off and pick-up. And finally, the number of passengers, we set it between 1 and 4. And then we look at the statistics of the properties again, always in a reasonable range.
Well, we will do some feature engineering now. So we filter only the file amount column to the target table. And then we create a new table, chain df, which contains all the other data of the chain collection with the file amount column removed. And now we roll the file test.csv, and we can see here the test collection contains only the input feature such as key, pickup datetime, and so on. And our goal is to predict file amount for each row. So firstly, we calculate the latitude and longitude difference of the test collection. And now we create a new table test.df, which contains all the data of the test collection. And we add a column isChain to the chain.df table and test.df table. And the values in the chain.df table is 1 and test.df has 0. And now we connect two tables in columns to the new table chain test, and we can have a look. So we can filter the year, month, and hour information from the pickup datetime column. And after that, we convert the pickup date time column into the format of year, month, day, so that we can get the day of the week. And we can have a look here, where Monday is 0, Tuesday is 1, and Sunday is 6. And we can also get a holiday calendar by using the function US Federal Holiday Calendar. And we can have a look here. In the column holiday or not, holiday is 1 and non-holiday is 0. And after that, we remove some useless information such as key, pickup date time, and we check the column information here, and we found that year, month, and hour column has the type object, so we convert them to the integer type. And finally, we get a table chain test with some derivative features like
Michel here. I'm going to talk about the two clustering, which in general lines is clustering the coordinates of the city, which means partitionating the city so that we would be able to work with each region separately and make the predictions as the taxi fare, which is the object of this work, and also predictions of the number of pickups and the number of drop-offs. Okay, so moving on. Okay, what we're going to cluster is the train test set, which is the result of the previous stage. Here the number of clusters was chosen as 6, but in my opinion we could improve it if we choose a algorithms that would be able to select the optimum number of clusters, and it would improve the predictions in my opinion, but we haven't done this. Okay, moving on. To do this work, we use the k-mean methods from the sklearn cluster, which is a library from Python. Okay, so we're taking the pickup longitude and the pickup latitude. Okay, so here we have the coordinates, and we're going to cluster these coordinates, which is 6 clusters. Okay, so here it's just in the part of fitting the model and getting the predictions. Okay, so the label is the result of the predictions. Okay, so here we're going to get the dummies. Why are we going to get the dummies? Because we're going to associate for each 0 that we don't have a pickup, and for each 1 that we have a pickup. Okay, so this is a very important step of the work. Okay, so and then here we're going to concatenate the cluster to the train test set. Okay, we're going to do the same thing with the drop-off longitude and the drop-off latitude. Okay, so here the same work. Here we're going to omit the is train column because it's no longer necessary. The string column was just a column that we used to fare the comparisons, but now it's not worth it to keep it. And here's the result. As you can see, we have the clusters, and we have an important information. Okay, for each event we have a 0 or a 1 into the clusters. 1 means that we have a pickup in this case, and 0 means that we don't have a pickup. The clusters free. So we can understand what happened during the city. So thank you very much. That was my part, and let's move on.
Okay, so now that we have cleaned up the dataset and setting up our clusters, let's see the importance of each variables. To do so, we have plotted the correlation between the variables. The correlation gives us information on how strongly a variable is linked to another. In our case, let's say that the correlation is the power of a variable to predict another one. For example, the pickup longitude can predict the pickup longitude with a correlation equal to 1 because they are exactly the same variable actually. In our case, we want to predict the fare amount. So looking at this column, we can see that taking the hour to predict the fare amount is not a good idea because of the correlation that's really low. it's equal to 0 actually. The only two variables that we can use to predict the fair amounts are the drop-off longitude and the pickup longitude, that are representing the pickup place and the drop-off place of the customer. In our kernel, we wanted to make a cluster of the data so we can predict them. So when we are looking in here, we can see that using let's focus on the first column. Look, using the day of the week to make our cluster will not be a good idea, because we have plot everywhere in here for the hours 2 and the years 2. The only plot that we can use is the latitude diff and the longitude diff that are representing the pickup place and the drop-off place, because there is a concentration of point over here and a lack of point over here, and the cluster will be more precise than using the hour to make it, because there is really too much point in here. So our idea is to use the longitude and latitude of the drop-off and the pickup place was quite a good idea to make a cluster of them.
Let's talk about now our modeling solution that we have here. First of all, we will just prepare the data for training. So we will do a random split with the random state equals to 42, which means that each time we run the function split, we will have the same results. So we want reproducible results, and we'll create then the xtrain variable and ytrain variable that will be useful for training our model, and the xtest and ytest variable to test our model. So here we have the train table, which contains the features of our model. So to go further, now that we have the training data, we can just compute a random forest that will use the training data here. And once we have trained our model, we know that the relationships between the features and the target, which is fair amount, will be computed. And the next step now is to predict with the testing data. So we made predictions, and after that we computed the mean squared error, which will compare the predictions that we have made and the real values that we needed to find. So the error here is 3.69, which doesn't seem really high for error price, so it's okay for the moment, but we can see that we can make some ameliorations. So here we have some feature informations. So we can see that for predicting the fair amount of a taxi drive, we have here the longitude difference, which is really important compared to other features here. So it's just to have the information about the features that are really important for our model. So after that, we can just rerun a random forest for the testing data and write the different results on the sample submission CSV file. So we have seen here that the error was 369, so it's a good thing, but we can do a better prediction. So there are 3 approaches to improve an existing machine learning algorithm. So the first one could be to use more data and feature engineering. The second one could be to tune the parameters of the algorithm, or the third one could be to try different algorithms. So we have done some researches that lead us to a deep neural network that could work for us, but we found this model of machine learning very complicated. So very complicated and really frustrating. So the best for us for our problem was to think about an approach that will use plenty of useful data to make better predictions. And we have seen so that with our researchers, we have seen that people are thinking that a simple model with plenty of useful data will beat a complex model with limited data. So for us, we think that for an amelioration of our model, the best path to follow is to get these data, these useful data that we didn't use, for example, or we didn't compute to make better predictions. So that's it for us. So we hope that all the explanations before were clear, and we hope that you enjoyed our kernel, because we enjoy it.